All right, so today we talked about equivalent expressions and being able to find equivalent expressions in a couple different ways. So we're going to start here with exponential and expanded form. If we have 3 times 3 times 3 times 3, we can say that we're multiplying 3 by itself 4 times. So 3 to the fourth is our number in expanded form. Same idea when we have a variable. So x times x times x times x times x, we're multiplying x by itself 5 times. So we have x to the power of 5. Our next problem is a little different, very similar. We've got 5 times 5 times 5, and then y times y. So we're multiplying 5 by itself 3 times, 5 to the third. And so plus here, we have y squared, y times y. I threw in this next one to trick us a little bit. This time we have m plus m. So if we had m times m, that's m squared. But if we have m plus m, we have two m's. So repeated addition is multiplication. Repeated multiplication is exponents. So 2m plus 3k is being multiplied by itself twice. So I had to put 3k in parentheses because 3k is being multiplied by itself 2 times. If I said 3k squared, that means that k is being multiplied by itself twice, and then we would multiply that by 3. So because we're grouping 3k, we have to put that in parentheses. Our next section is on combining like terms. We talked about terms. Terms are either numbers, variables, or a number with a variable being added or subtracted in an expression. So in this problem here, 10a is a term and 5a is a term. Now I can only combine terms, add or subtract terms, when they have the same variable, when they are like terms. So like terms are when the variable is the same. So I can combine A with A, but I cannot combine A with B. So if I have 10A and 5A, they both have the variable A. They are like terms. If I have 10 A's and 5 A's, that's 15A. You could add apples with apples, bananas with bananas, but we can't add apples with bananas. So we have to have the same variable to be able to have like terms, to be able to add or subtract them. So if we look at our next one, we have 7b, 6, and then we have minus 3b. We have to keep the sign with the term. So if there's a sign before the term, we have to keep it. I like to circle and square to group things. So I circled my 7b minus 3b. 7b minus 3b is 4b. I can't forget about that 6 plus 6. 6 is not a like term because 6 doesn't have a b, doesn't have a variable. So I just leave it as 4b plus 6. If I look at my next problem, this time I've got two pairs of like terms. I have 12c plus 3c. So 12c plus 3c is 15c. And then I also have 8d minus 4d. Keep the sign, minus 4d. 8d minus 4d is 4d. So that's our expression. We have C, we have D. A reminder about repeated addition again is the same as multiplying. If I have 5 E's, 1, 2, 3, 4, 5, and I'm adding them, that's the same as 5 times E, 5 E's. My next problem again has some like terms. I have 9x minus x, keep the sign. Minus x, there's always like an invisible 1. This means I have minus 1x. If I have a variable and there's no coefficient, there's always like an invisible 1. So if I have 9 x's and I take 1x away, I'm left with 8x. I also have 6y plus y, which is 8y. And I also have this constant that's on its own, minus 7. So my simplified expression after combining like terms, 8x plus 8y minus 7. There's nothing else I can combine, no more like terms, so I'm all done. Our last section here for finding equivalent expressions is using the distributive property. Remember that we're multiplying our 7, our number on the outside of parentheses, by both numbers on the inside of the parentheses. So 7 times 5a and 7 times 8, multiplying the 7 by both numbers inside. 7 times 5a is 35a. 7 times 8 is 56. So that's how we rewrote using the distributive property. Our next problem, we have our 6 outside the parentheses. 6 times 8x. This time we have a minus between our two numbers in the parentheses. And we can't forget 6 times 4y. So I have 48x when I do 6 times 8x minus 6 times 4y is 24y. Our last problem is just a little bit different. We're going backwards this time. So we're going to pull out our common denominator and rewrite using what we know about the distributive property. I'm going to use 6. I know that 6 is a factor of both 36 and 48k. So I'm going to say 6 times 6 is 36, and 6 times 8k is 48k. My common factor goes on the outside of my parentheses, and my two other numbers, 6 and 8k, go inside the parentheses. You could always redistribute this out and see if you get back to what we started with. So 6 times 6 and 6 times 8k is 36 plus 48k. So you could always use this to check your work. Let me know if you have any questions. Practice, and we'll keep working on this.